we're recording.
It's happening. It's finally happening.
Oh no, it's my worst nightmare.
I mean, we've been putting it off for a while. I mean, whether explanation could suffice to explain.
I don't know what you're talking about. We've been planning to do 3 versions for every podcast.
You remember the last podcast when we said, hey, what a weird thing, we're doing 3 versions. Definitely won't happen again. And I'm pretty sure, we were pretty confident it wasn't going to happen again. And then it happened again.
No, this is when, history is written by the victors, Ben. We can just say that
we own the website. We can just change those sound files. We can go back and re-record the episode.
That's right. Exactly. We never said such a thing.
History is mutable.
So I do want to give a warning ahead of time here, which is that I do have a cat that's trapped in my office because she had to go to the dentist. And so she's a little loopy and crazy. So if you hear weird sounds of a cat meowing and running around, it's just my cat being crazy.
Noted. There's no cats at the library.
All right. How about we dive into 165, Ben?
Let's begin. We've got a lot of work through. We've got an hour and a half to do it.
I guess we can start with the headline feature that everyone is screaming for,
clamoring for
through the podcast medium,
or clamoring against, possibly.
Yeah, and that is, of course, JATS.
JATS, as the creator of GIFs would say, George Jefferson.
That's right. All right. What are these GATs, Ben?
Well, I mean, basically, there's 2 ways of explaining it. There's the easy way, and there's the very involved way. The easy way is, like generics. You've heard of those before, right? Like associated types. You've probably heard those before. This just lets you use generics and associated types. It's kind of like conceptually, that's all it is, right? It's like, previously, if you had a trait and you had a type into it, you couldn't have generics inside of that type, and now you can. And this allows you to do a lot of new things, and it's a very powerful feature. Suffice to say, it's not that simple under the hood. It's a lot that needed to be done to change the compiler. Because this has been a long in progress feature for years now. And type theoretically also, it's pretty, they would say expressive is the word they would use for kind of like, anything that lets you do totally wacky and crazy things with type signatures. So why don't you take it away, John? What do you think? Can you explain the convoluted answer to this question? What is JATS?
Well, I don't understand all of the debate here, because isn't this just higher order type programming? Like Haskell has had this since like 1998.
Obviously, it's a monad in the category of endofunctors. Come on.
Yeah. This is just kinds in type theory. I don't get it. Now, so I'm going to probably botch this explanation because I'm not a type theorist, but the very basic premise here is that we've always had generics. That's fine. So generics is when you have a type that is parameterized over some other type. Now, where this gets weird is when you have generic associated types. What that means is you have a type that is generic over a type constructor. So that is, it is generic over something that itself is generic over a type. Hence the higher order bit here. And it turns out that once you want to go that extra level of being generic over something that is itself generic over, it really messes up your type system. Or rather, there's a bunch more stuff you need to figure out how it's going to work. And that's something that they now have landed there. There are some caveats to this initial landing of GATS. We'll link to the blog post that goes in a little bit more detail and some of the restrictions that they're landing for this, let's call it the 1.0 release of GATS. The MVP. But so more to come in this space, but the basic premise here is just now you can have associated types that are themselves generic, and that means that now you can do more abstraction. Basically, you can write more abstract traits. Or rather, you can use traits for more things or to capture more kinds of generic behavior.
Are these higher kinded types? I've heard of HKTs before, and you're the only one here with any kind of Haskell expertise, so.
I don't know that expertise is the word I would use, but I have dabbled in Haskell, which I guess counts. So higher kinded types are sort of like this. This is not full-blown higher kinded types. Higher kinded types are
less powerful.
So higher kinded types is that you can have trait bounds that express that they apply for all types that are generic in a certain way. So it's a more general purpose mechanism than just generic associated types. But I do think that generic associated types are an instance of higher kind of types. It's just that they're not the full thing that people talk about when they talk about higher kind of types. Don't at me.
Don't at you. Well, I guess so the big reason why this matters is because if you're really into async Rust, you're curious, maybe you're holding off on async Rust because it kind of like, it's been described as an MVP itself, right? And one of the things that's keeping it in MVP status was waiting for this feature, right? And so this, in conjunction with another upcoming feature, which is the ability to use impl trait in more contexts and more areas of Rust code, will make it possible to do async methods in traits. So the idea here is kind of like, where today you need to use David Tolnay's async trait create, where it will, you can slap that procedural macro onto a trait or an impl, and it will rewrite your code to make it, any async FNs transparently return boxed futures. And so today, that's kind of a bit of a performance penalty. In the future, the idea was you should be able to just kind of return unboxed futures from any kind of method that wants to return a bog standard future, right? So this should allow that and enable that. And so right now on Nightly, this is actually usable. If you wanted to play with this on the Nightly branch of Rust, you can. You can try. I think it's still a bit restricted. I think there's still some things to implement, but I think they're kind of
we'll link to the blog post that specifically talks about GATS and about the MVP status of it. That has a bunch more details.
Yeah, totally. I think we should let the blog posts speak for themselves because they are the experts and we are not.
And you know what else we should let, Ben?
What else we should let me talk about now?
Let else statements.
Yeah. So if you've used Rust before, you've probably seen a match statement, right? So imagine you have an option. An option can either be some or none, but you want the thing. You don't want the option. You want the GUI center. You don't want the Tootsie Pop. You want the gum inside. And so you have to crack it open. And to do that, you use a match statement usually. I say usually. You can, fundamentally, the most basically is you match on the option and you say, hey, if it's some, if it's got the GUI center, then chew it. Otherwise, take it back to the store. You got a bad Tootsie Pop. And very often, this kind of pattern involves the none branch of an option just not doing anything. Kind of you'll see it kind of some foo and then the arrow and do a thing, and then below that a single kind of empty atrophied match arm where it's just kind of a none arrow, empty braces, empty parens, kind of sadly hanging off the end there, being useless. And so it would be nice if we had kind of a nicer, more convenient syntax for this. And so the language Swift does have this, and this is where Rust gets it from. This is called an if-let kind of pattern. And the idea here is you can do a thing where, essentially an if expression that only gets taken if a certain match, if a single match succeeds, right? So if you have an option, you can say if let some foo equals your option, and then inside that new block there, the usual you'd see in an if expression, you can do whatever you want, and then like usual in an if statement, it will fall through at the end of the block and continue on.
But Ben, this moves all my code so far to the right, though.
Right. So kind of you can think of any kind of branch. It's interesting, right? I don't want to pontificate about the idea of what branches are and structured programming and such crazy insights we take for granted for just common patterns of the idea of, oh, if you have a branch, it does normally fall through at the end of the block and doesn't all the time cause you to duplicate your code or call new functions or do anything. It's crazy how we have this 50-year long history of nice programming concepts to fall upon. But in this case, the happy path, you might say, of the sum, where something happens, requires you to indent. And what if the option contains an option or a result that you want to do a thing on the OK branch? You're going to be constantly kind of indenting more and more and more stuff. And then if say the none cases are super boring, it means that at the very end you'll have kind of very you'll have this function containing a pyramid of power essentially, where it goes longer and longer and longer with all the logic inside, and the very end kind of is a nothing on the unindented path.
Yeah, at the end you just have this cascade of closing braces.
Yes. And so very often, this is where the idea of an early return comes in. So in a normal if expression, if you wanted to very often you'll say, hey, in this function, I want to return early if something happens, right? And so you might see an explicit if statement, if expression, where if foo equals true, then return with an error or whatever value you want to save, right? And the reason you do early returns there is because the alternative is like this idea of having this like big cascade of ifs. And the nice thing is, just for readability, you can leave the happy path logic on like, a single indent in the function, and it kind of like just proceeds like that. And like, if you've ever used the question mark operator before, this is kind of what you're doing, right? You're not like making a whole new branch for the happy path. You're also not even bothering to write out the, if foo equals error return. You're just like making it happen automatically. And so here's the idea. This if let form lets you do things in the happy path. You have like a sum or a thing, but only if you have a single, like, only if a thing succeeds, only if you have like the thing you want. Enums can contain multiple variants. They can contain many things, and you can't really, in an if let, say, hey, like, do this or this and bind it to the same thing and then equals this, right? I'm pretty sure you can't. Maybe you can, actually.
You can. You can use or in if let.
Interesting. Anyway, so the other, anyway, it doesn't matter, because the point is kind of like, if you want to do an early return for this pattern of like not cluttering up the happy path with indentation and leaving all of the error handling for the very end, you can do early returns with error handling with this new let else construct. Let's also think about the idea here is, you've heard of pattern matching in let expressions, right? So you can do, like, we have a tuple, like foo. So you have a tuple of like, a tuple of 1 and 2. You can say, let parenthesis x comma y parenthesis equals foo, and now you have variables in scope that are x and y. And so you probably, if you've used Python before, you've probably seen this before. So Python just has, parenthesis xy parenthesis equals, foo, and it'll bring this into scope. And the idea is you can do pattern matching on things to actually bring them into scope. And so what's neat is that this works. It's either that it works, right? But if you think about it, it only works in certain contexts. This is called an irrefutable pattern, where in order to, because what if, obviously in a tuple, you can't ever fail to match x and y because there's no like conditions there. But in an enum, you have two branches. You have like a sum or a none branch. And so you can't just say, let sum foo equals whatever option you have, because like what happens in the none case? And so other languages actually, with pattern matching in let, take a different stance here. So I believe OCaml, if you do this, it will just panic implicitly, right? And so if you try to like, if you try to do a let sum equals whatever, it's kind of like saying an unwrap essentially.
Yeah, it's like unwrap.
So it's like unwrapping, but in a let, right? And so you could do it in Rust. You would just say, let x equals, option.unwrap. But so kind of like conceptually, like what if like you want to like not do that? This is where also if let comes in. You can think about it this way, where it kind of lets you make bindings for refutable patterns, where like the branch that you take when the pattern succeeds, that's the whole like the universe where your nice happy code goes, and then beyond that is the dark dungeon where whatever did the quote unquote the panic. So you could have like an if let sum foo equals your option, do a thing, and then below the if statement panic would be the same thing as having let x equals option.unwrap. And so this new let else statement is kind of the alternative to that, right? The duel, the mathematical duel of if let, where it lets you bring a thing into scope. It lets you use pattern matching on anything, right? Because you can use pattern matching on not just on enums, but on structs and on tuples and on arrays and all these kind of things. It lets you pattern match on a thing and then say, hey, like if this match failed for whatever reason, take this branch, right? This is my error branch. And what's neat about this is that, first of all, the syntax is kind of like, let. It's just, there's no if let. It's just let x, whatever pattern, equals thing, like you expect. And then afterwards, an else. And then the else must have a block after it. That's like everything else in Rust. And then inside this block, this branch, because it's a branch, must diverge. And by diverge, we mean it can't ever return to the enclosing scope. And it can't ever kind of like fall through beyond the end of the block.
Yeah, because it wouldn't provide anything for the pattern.
Yeah, because in the outer scope, the nice unindented, like flat scope down below, we now assume that this thing exists. We have bound a variable to a thing, and in the else branch, we only take that whenever it doesn't exist. So what would you do? And so this new thing, so you by diverging, we mean it must either loop forever, or it must like panic or call like, OS exit, or it must return from the function, right? It doesn't have to mean that you bring a crash. It could just mean kind of like, hey, like, early return here.
Yeah, or break the loop or whatever.
Or do something, right? It must guarantee that whenever whatever scope that you return to doesn't try to, doesn't want to contain the value that doesn't exist, right? For safety. So it's, doing the right thing here. And so if you are a firm user of if let, yeah, you should probably go through your code and say, hey, like, is there anywhere I could be using let else and like make my code nicer? I believe that when they were like, testing it for stabilization, somebody went through and like submitted like, a long series of like many PRs to like port the compiler itself over to using it. And it made things look nice. I really enjoyed how it looks. It kind of like, it feels like a complete feature. Like it feels like, now it feels like with this, if let is now like a complete thing because it's no longer, oh, I wish you could do this with this. And I will say there's still like one thing left. We'll get that later, right? There's a let chaining would be nice too, but we'll get that in a sec.
Yeah, I wanted to call out a crate called if chain. That's also really nice for this. So this is a little bit beyond just what you can do with let else, which is imagine that you want to do, if you want to do a bunch of patterns to some deeply nested thing, and only if all of the patterns match, you want to do something. So you don't want to do an early return, so else doesn't really apply because you wouldn't be able to diverge. But you just have like a, if let something equals something, and then inside of that you have if let something else equals something else, and you have that nested 5 levels deep, and at the bottom there you run some logic, but then you fall through at the end. The if chain crate lets you do that without the million lines of indentation, which is pretty nice.
Yeah, so I think this is a great feature here. I'm happy to see it succeed. It shows off Rust's cool pattern matching thing. Like, I think pattern matching is one of those things where, like, it contributes to the idea of, like, you use Rust for a while and then, like, you don't want to go back to other languages because kind of, like, secretly, like, one of those, like, many small features, like pattern matching, kind of, like, it's so convenient and nice to have. Because in case you don't know, you can use pattern matching in many places. You can use it in function arguments. You can use it in closure arguments.
Yeah, it's just that some of those require the patterns to be irrefutable, whereas here they can be now refutable as long as the else branch diverges.
Yeah. Anyway, I've gushed enough about let else. I think it's a really cool feature. Let's move on. Break from labeled blocks. So, John, want to talk about this?
Yeah, so this is a pretty natural extension to something we already have today, which is labeled loops, right? So currently, if you have especially just like an actual loop with the loop keyword, but also for loops more broadly, like for loops and while loops, you can label them by putting, tick or a single quote, and then a name, a label, colon, before the definition of the loop. And that way, inside of that loop, you can call break or continue, and then single quote and that same label to break or continue that particular loop. And this is useful if you have, for example, nested loops, where you might want somewhere in the inner loop to break or continue from the outer loop. The way you have to do that is by labeling the outer loop and then having the inner break or continue refer to that outer label. And now we have the ability to label blocks as well. So not just things that are loops. And the idea here being you might have, nested blocks where you effectively want to sort of early return, except you don't actually want to return from the function. You just want to early give a value to a block. And so this is really just, it feels like rounding out and does also help with this, a similar kind of thing to let else, where you have these, you otherwise end up with these endless like nested if else's or branching statements, because you need to ensure that the value of the whole expression evaluates to what you want. Whereas now instead you do like, if the early value expression is true, then you break out of the block with that value. Otherwise, you keep doing the thing that you would otherwise have to nest in an else block. So this too is just a nice way to make your code more readable, really.
Right. And now that we have this, now that we have break from labeled blocks, now that before you could always, in any of these like, loops, you could always return, or not always, at least in one of the loops, you can return a value from the loop with the break. We don't even need the return keyword anymore, right? We can just like remove the return keyword, and you can just like, label the functions block, right, with a lifetime, and then just call break, right? So it's great.
I mean, you could. Do you want to?
But it's so much simpler, John.
I see. You're obviously right.
As usual.
So this next one, splitting Linux debug info, is one that we have talked about a little bit before in Rust 151, where split debug info landed for Mac OS. And the change here is just that it's now landed for Linux as well. And the idea here being that debug info is like the thing that records the name of your functions and variables and whatnot that make it easier to debug a Rust program after it started executing. So it lets you take, the addresses, the offsets in your binary and turn them back into, oh, this is this line of this function, or this memory location is this variable. That debug info is normally stored just is like burned into the binary, which makes the binary itself very large and can also have an impact on things like performance. Whereas with split debug info, which we, again, have already had support for on macOS, you basically get the debug info in a separate file that debuggers know how to find and read, which can be really nice just to have smaller things to ship around, but also can actually improve the performance of your binaries as well by virtue of splitting out that debug info and making the binary itself smaller. It's still off by default on Linux, but now you have the option of turning it on. I don't know whether the plan is to turn it on by default in the future, but at least for now, it's off.
Up in the stabilized APIs, the only one that I want to call out is the stood backtrace type. Backtrace type in the backtrace module, which is, I don't want to spend too much time on this because I think in the future we'll be able to talk more at length about the idea of error handling improvements in the standard library. But I think right now anyone who's used Rust seriously has probably seen the anyhow crate, the IR crate, any of these crates that make error handling more convenient. And one of the author of IR, also the author of anyhow, they're both on the library team and working on the error handling project group. So I believe that the idea is in the long term to make the standard library more in line with what these crates do. Kind of the idea of deriving display and making it all convenient to construct and pass around and convert between more error types. So I think this is an essential feature. It's been blocked for a long time on various refactorings in standard library. I think in the future, the idea here too is that the error trait itself will be exposed from core as opposed to stud. So look forward to that. And I think if you care about, if you're really into Rust error handling, look into the backtrace type in stud now. I think you'll be pleased to see progress on this front.
Yeah, one thing that's interesting, I think, about backtrace is that, and one of the reasons why it took a while to land is because there's a bunch of configuration around backtraces. Like, for example, you can set the Rust backtrace environment variable to essentially turn off backtraces. And so the backtrace type that just landed instead has this little note saying, in some cases, the backtrace type may be internally empty. And so there are still some caveats here, but they're sort of intentional. And it used to be that I think the backtrace was provided through a separate crate called backtrace, which I think was nightly only. I forget exactly. But at least now having it, on stable and in the standard library is a really nice win. I wanted to call out briefly to the finalization of the RLS deprecation. We've talked about this in a previous episode as well, but basically now RLS, the old Rust IDE integration, is now fully deprecated. So if you install it through the RustUp component called RLS, what you get is really just a small proxy LSP thing that will respond to every editor command with, this command does nothing, you should install Rust Analyzer instead. Which I think is a kind of neat way to approach the problem, to ensure that people who were still relying on RLS actually get a note telling them to upgrade. I've also done my usual deep dive into the changelog, and a couple of them are actually called out in the other changes list in the blog post too. One of those is the fact that Cargo will now be smarter about the order in which it compiles your dependencies. And this, I'll link to some of the detailed analysis that's gone into this. But very basically, it only really matters at small core counts, usually things under 8 cores. And this turns out to apply a lot to CI, for example, which is one of the reasons why it's really valuable. But in those cases, Cargo used to just build your dependencies in sort of FIFO order. So as it discovers a dependency, it sticks it on a queue. And when it has capacity to compile another crate, it'll just take whatever is at the head of the queue. And the change here is that instead of taking just what's at the head of the queue, it's going to look through the queue for the thing that unblocks the most other crates down the line, and that way ensure that you get to maximize the use of your parallelism all the way out through your build, rather than having these stretches where maybe you're only compiling 1 or 2 crates even though you had more cores available. So it's a really nice win. I think they did a bunch of benchmarking for this, and they saw many crates where this gained a compile time improvement of like 7%. I think the highest they measured was like somewhere in the vicinity of like 15%. So it's a pretty cool improvement for, especially for CI builds, but in general, low core count builds.
In the detailed release notes too, I want to talk about the more exotic enum layout optimizations. So I think that, so in Rust, enums, they're not just unions like in C, they're tagged unions. And so they are unions that also at runtime carry information about which variant is currently active, is the one with the data right now that you should interpret it as this kind of variant. Right? And this is a runtime, it's dynamic, so it has to take up space somewhere. And so naively, this could result in enums not being a zero cost abstraction. It could, be like, usually there's not more than, a few hundred variants in an enum. And so 1 byte suffices. And so kind of like, ideally, it only takes 1 extra byte to convey the information, but because of padding and alignment, this can sometimes double the size of an enum compared to the optimized version. And so the way that Rust deals with this is the idea of niches, the idea of having unused values in any given type that it can kind of like hide the variant data inside. And so the most famous case is if you have an option of a reference, because references can never be null, they always have a non-null value, you can save the single bit of none in null. And so if you ever have, in memory, if a value of an option is ever null, it means it's none. And so kind of becomes a zero cost abstraction. And there's a lot of optimizations this way to kind of like be clever about like using less memory of enums, storing data for them in various places. And you have to be careful because sometimes you can like take, references to certain fields. So they still need to be aligned. You don't have to have, reorder things dynamically to access a thing in a certain case. But in this case, now it's possible to, in the example before where you have an option with a none, it doesn't need to contain any data. So none is only ever 1 bit at most of information. So we can just, as long as you have 1 bit free, you can store that information somewhere. But if you have enum variants that contain data, that's harder because they are larger, and so you need a larger niche, right? And so you need to find now with 65. If you have a large enough niche and you have small enough variants that contain data, it can now intelligently insert those variants into the niche, resulting in possibly really good improvements to memory usage.
And this should also be entirely transparent, right?
Yeah, there's no way to observe this. I don't think there's any in this case, any like runtime. I think there's no downside really. I think it's just a matter of the compiler being smarter and understanding more about your types and like how it can lay things out intelligently. So,
yeah, it's pretty neat.
Yeah,
I had a couple of others. So one is there's been a change to polyfen, which I think landed only in the prior Rust versions in 164. So polyfen is a type that's used sometimes in async programming, and it used to unconditionally implement unpin regardless of whether the inner type was unpin. And there's been a lot of discussion about some unsoundness that was discovered as a result of this, or as a result of how this enabled people to write code that turned out to be unsound very easily. I just wanted to call it out. I'm not going to go into details here, but I'll link in the show notes for anyone who's curious about why polyfen has to not be unconditionally unpin. Another regression that was called out in the release notes was that, and I thought this was funny, as of Rust 165, you'll now sometimes get an error if you combine too many different programming languages in your linked binary. This is a regression in LLVM. After the upgrade to LLVM 15, where now, for example, if you compile Objective-C and C++ and Rust and try to link them together in the same binary on a macOS target, this, for example, turns out to happen with Firefox, LLVM complains about too many personalities, which I think is fantastic. And the origin from this is that personalities is the way that LLVM encodes particular language-specific behaviors that are needed. And so there's like an Objective-C personality, there's a C++ personality, and there's a Rust personality, and now there are just too many personalities. I also like that the personality for Rust is called Rust personality, like EH. It's very funny. What else did I want to call out?
I want to talk about one of these too.
Oh, yeah. Yeah, go ahead.
Which is that the uninitialized integers, floats, and raw pointers are now considered immediate undefined behavior. And so I think
what do you mean by immediate?
We've talked, I think, at length before about maybe uninit and the whole kerfluffle over like, so there's a function in the standard lib called mem uninitialized, which is like definitely the like single most regrettable like API ever stabilized. It was a 1.0 thing. It was kind of like we were more naive back then, right? In terms of like what it might mean to like, have memory that's uninitialized. And the obvious example is if you ever have like a Boolean legally in terms of Rust, a Boolean legally Rust will come to your house. It's a very strict language. It will if you ever have a Boolean whose value contains anything except 0 or 1. It must be 0 or 1 exactly. And this is important. I talked about niches before, right? If you have Booleans, if you have enums that contain Booleans, Rust is smart enough to know that it can use the entire rest of the Boolean, all the rest of the, it's not a single bit, it's a Boolean's a byte on disk. It can use rest of that memory to encode niche information, right? And so, like, this is actually useful. It's important, not just for making sure that, you don't do, not just for optimization's sake, but also for, storing information at runtime. So it's crucial that no non-0 or 1 values ever get placed into a Boolean. And if you use mem uninitialized, which part of its contract says we have no idea what this will contain, it is just an immediate undefined behavior because of this invariant. With this, I think it's called a validity invariant, where there are invalid values that are. It's pretty obvious, kind of like, right. So you have 2 valid ones, and the rest are all totally verboten. What's less obvious is that this also applies to integers, right? And think about like, an I32, like about a U8, right? U8s are simple. At 0 to 255, those are the only values, right? And there's something illegal about that. You could like, you can even like wrap through and like count through all of them if you wanted to over and over and over again with the wrapping type, of course. But this is kind of, again, a bit of a naive way of thinking about things because of what optimizers do and what it means to be like, an optimizing compiler. You may be surprised to learn that there is in fact one extra value that these types can be in, which is undef. It's just known as undef, which is internally kind of a thing that compiler backends use, at least LLVM, right, uses to indicate whether or not a value is defined or not. So it's a 1-bit kind of value, right? Like either your value is defined and it's either a 0 to 55, or it is undefined. It could be anything.
And to be clear, this is not stored. This is like stored at compile time.
Yeah, this is not a thing that exists at runtime. This is only a compile time thing, but the idea is because the optimizer is compiling on the assumption, using this data at compile time, it has to remain true. And the funny thing is that if a value is undef, the value is not guaranteed to change at any point, right? It can never be solid. You can never observe it and then get the same thing back. And you can never guarantee to get the same thing back, right? If you have an undef value, it's totally possible, as far as the optimizer is concerned, to read the value 4, and then next time you read the value 22, even though nothing has changed. There's no reason for it to change. And to explain why is totally out of my pay grade. It's like silly optimizer stuff. Optimizations are an entire field of their own. But these things like this are the reason why Rust can be so fast, despite offering such a high level of abstraction, right?
Yeah.
So it wasn't clear for a long time whether or not people really wanted to like make this kind of guarantee in the language itself. Whereas for Bool, it was obviously broken. It was less obviously broken for integers and other things like that. And now this is just changing the docs to kind of be like, actually, no, we've decided that it is in fact broken. Don't do this. Instead, use maybe uninit.
Yeah, and we'll link to the issue that and the PR that discusses this as well. There's a lot of interesting discussion there if you want to dig in deeper. And it turns out that if the compiler knows whether or not a value is undefined, it can just be smarter about optimizations, and we should let it do that. The last thing I wanted to call out from the changelog is an uplifting of a couple of lints from Clippy into proper Rust C lints. In particular, the lints that have been added are let_drop and let_lock. So these Clippy lints you may be familiar with already, which is if you ever write let_equals, some mutex dot lock, Clippy will yell at you saying, hey, you took this lock, but let_equal immediately drops the result of that expression because it doesn't get assigned to anything. And therefore, you're not actually holding the lock for the remainder of the scope, even though maybe you think you are. And so this is a sort of correctness lint, essentially saying, specifically for mutexes, where you are taking a guard and then immediately dropping the guard, which releases the lock. And this was deemed a valuable enough lint that it's now been upstreamed into Rust C itself. So you get it even if you just run, cargo check. You don't have to run Clippy to get it. And let underscore drop, I think, landed as an allow lint only for now, which is a similar, let underscore equals expression will now warn you saying, hey, this expression does nothing. You're immediately calling the drop on whatever value this expression returns, which may not have been what you intended. And I thought it was interesting that these were deemed valuable enough to actually turn into real Rust lints. And it's a good point of interest or point of data for if you have an idea for a lint, maybe it's useful to land it in Clippy first, let it sort of ruminate there for a while and brew, and then eventually maybe it'll prove itself and get adopted into the standard library or into the Rust compiler itself.
One last thing for me from the detailed release notes. If you've heard of the non-exhaustive attribute that you can apply to enums, the idea here being kind of as a concession to library authors, where if you want to expose an enum but don't want to give any guarantees that you won't add things in the future, so if you have like maybe an error enum where you want to be able to in the future be able to add more variants to your enum without breaking any kind of downstream consumers, you want to prevent people from matching exhaustively over your enum. Right. That way they cannot, people cannot get miscompiled code or not miscompiled, get compiler errors, right? From a minor or a version of your library that adds a new variant, allowing you to do fewer breaking changes or fewer major releases, right? But you may be surprised to learn that you can also put non-exhaustive on individual variants. And so if you want to allow people to match over your enum and do certain things, I guess maybe I'm not even sure if matching is allowed, but at least in this case, for an enum, you can as cast certain enums if they have if they're C style integer enums. You could say f as u8 to actually get the actual discriminant value out. In this case, you can actually prevent that with a non-exhaustive attribute on the variant itself. And so that was a fun little thing I learned today from reading this release notes.
I think that brings us to 166.
Yeah, we're moving along.
That means we're halfway, right?
Yep, halfway there.
That's how numbers work.
Living on a prayer. Let's do it.
All right. So the headline feature of 166, I don't know whether it's really a headline feature, but it's the thing that came first, which is explicit discriminants on enums with fields. And I have a feeling, I have my spider senses tingling here, Ben, that you might have something to say about this.
Right. Like I was just saying, a good segue here. If you have an enum where you have said, hey, the representation here is a certain size, this enum is a U8 or whatever, you can give these variants certain values, which is great for doing interop with C programs, because in C, an enum is just like basically a list of integers, right? It's kind of like, you have an enum in C where it's kind of like you have A, B, and C. In the enum would be kind of like 0, 1, and 2. Essentially, they are just kind of they are transparent aliases for integers. So you can use, the enum's A variant as the number 0, which is it's great for self-documenting code and making things easier to read. But it's in Rust. If you want to interoperate, that's good for doing that. But in some cases, I'm not really sure when. I guess some folks, essentially in Rust, if you have, like I said, this is previously only possible if your enums were C style, quote unquote, where they didn't contain data. Nowadays, if they contain data, you can, in fact, give them actual discriminants explicitly. They do still have to use repr u8 or repr so-and-so on the enum itself to opt into this. But now you can do this. And you may be wondering when this is useful. And I'm assuming it's almost never useful. It seems like a very specific kind of for C interop concession.
Yeah, this strikes me as really weird. Like the example in the changelog is you have an enum foo, and one of the variants is C that contains a bool equals 42, which I think means, okay, this variant is a Boolean that's represented as a U8, and its discriminant is 42. But if I store a true in that C variant, what bit pattern is stored? If I store a false, what bit pattern is stored? I don't understand, Ben.
We don't ask questions. We only accept. Yeah. So I guess normally in most enums, if you don't have an explicit representation, it doesn't guarantee what it will be. And I assume that whoever asked for this had a very specific need. And I'm sure for them, this is kind of one of those oh, finally. But for me, I don't really understand it. And I think you should be careful doing this if you do decide to try this for secret reasons, for secret dark purposes, which we won't mention them here, but we will link in the release notes to the dark purposes. If you want to learn the hidden dark secrets of Rust, follow the release notes and click the link if you dare.
Yeah, it sounds pretty scary. I don't know if I want to. I don't know if I even want to click this because I don't. This sounds terrifying.
I said it because in the blog post here, I had to actually submit a PR to explain more things to the blog post because it was not clear to me when it first came out what this was useful for or how you would even use this. So even the folks who wrote the blog post were kind of baffled as to this feature.
Yeah, I mean, I found the RFC and I still don't understand. I'll link the RFC in the show notes so people can dive into the deep dark depths here.
And it's appropriate that this is Rust 1.66. It's quite, wouldn't you say? It seems like an appropriate number for something so demonic. In fact, the next thing here, I believe that Jon has an axe to grind for core hint black box. Jon, grind that axe.
Okay. All right, so let's talk about black box.
I love black box. It's so good.
So black box has been in the standard library for a long time, but it's been unstable. And one of the reasons why it has been unstable for so long is because there's been a lot of debate about what black box does. And not just how it's implemented, but rather what should black box promise that it does, if anything. Now, for those who aren't familiar, black box is an identity function. So you give it a T and it gives you that same T back. Like it does not change the T in any way. It is literally just that. And the semantics of black box is, as the module it's in, hint, suggests, is that it is a hint to the compiler that it should treat that call as a black box. So that is, the compiler should think that the T that goes into the black box is completely unrelated to the T that comes out of the black box. And it's not a guarantee that the compiler will not remember anything about the transformation between these two values or the connection between them. But it's a hint to the compiler that, if you think that you knew something about the T that went in, don't assume that you know the same thing about the T that came out. And the reason why this is useful is usually for things like benchmarking, where if you don't have a mechanism like this, the compiler is just too smart. It optimizes your benchmarks. It realizes that you're calling it in a loop and just goes, oh, this doesn't do anything. You could just unroll this loop or just don't call it in a loop at all because there's no end visible state for this execution. The thing that you call inside the loop is loop invariant, so we're just going to hoist it out of the loop. Optimizers are too smart for benchmarkers' own good. And so you need a mechanism like black box to hint at the compiler, hey, don't be smart here. But again, it took a long time to stabilize because both how do you document this, but also what do you actually guarantee? Because you don't want to say this guarantees that the compiler won't know anything about the connection, because then people are going to start relying on it for things like cryptography and hiding secrets and stuff. And it doesn't work well enough for that. We can't actually tell the compiler, hey, forget everything. All we can do is try to hide some of this stuff from the compiler so that it doesn't do all of the optimizations it might normally do. And there was a long debate about what name should this have, what module should it be placed in, what should the documentation be. And ultimately, it landed in the hint module, which I think is about right. The name black box is sort of unhelpful. It's only useful if you already know what it does. But the problem is none of the other proposed names were really all that much better. And so in the end, it landed as black box just to avoid churn in the ecosystem. There are so many crates that already assume that this function is called black box, and telling all of them to change as a result of the stabilization feels kind of unnecessary. And so therefore, given the absence of an obviously better name, it landed as core hint black box. But again, keep in mind, it is a hint. It is not a guaranteed function where you absolutely positively can rely on the fact that no optimizations were performed. It's also pretty hard to use, right? So what black box does is only tell the compiler to forget any association between the input and the output. But that doesn't mean that it won't optimize the expression that you gave in, for example, or optimize the value that you got out. It's just the connection, which means it's still pretty hard to write good benchmarks even when using black box. And the documentation of Blackbox talks a little bit about this. Basically, it's a function that has a lot of caveats and a somewhat non-obvious name. And as a result, it's a weird thing in the standard library. It sort of has to be there, and it's very valuable, but it's here be dragons.
Yeah, it's kind of like, I don't know. I didn't see any of the proposals for other names. It's kind of like, it mostly just blocks the compiler from assuming that something isn't used. It lets the compiler say, hey, like, this thing is quote unquote used. You can't like get rid of it.
Well, so that's one of the side effects.
Mm-hmm.
But there are also other optimizations like, well, there's a lot of stuff here, but basically the compiler can't optimize the output value based on things that it knew about the input value, which turns out to have other implications as well.
I'm sure that's all very important, people who care a lot about benchmarking, but for me, what I care about most is just making sure that the thing I'm benchmarking doesn't get totally sent away. And so I think for simple use cases, it's actually like totally fine if you're just doing like, if you want to say, hey, like, is this like function faster or slower in like a micro benchmark? I think it will suffice for what you want to do.
Yeah, the problem is it doesn't work that way.
No?
So people use it that way, but it doesn't actually guarantee that.
I'm not saying it guarantees it, but I'm saying it's pretty obvious when it doesn't work.
Well, so for example, if you had a function call that you wanted to call in a loop, then calling black box and then putting the function call inside of that black box call does not actually guarantee that it gets called in a loop. It can still be loop invariant and be hoisted out.
Mm-hmm.
This is one of the reasons why it's somewhat counterintuitive, because it's not sufficient to just like slap a black box on it and now it doesn't get optimized out.
But what you would do is you would bind it inside the loop and then pass the bound variable into black box, right?
That also wouldn't be sufficient. You would need to black box a variable that goes into the function as an argument, and you would need to black box the output of the function so that it doesn't assume that the function is unused.
I see.
Basically, here be dragons. The next one is a pretty short one, which is, in Rust 162, we got cargo add for conveniently adding dependencies to a cargo project. And now there's also cargo remove, so you can remove those dependencies afterwards. So this is a nice quality of life win. For stabilized APIs, span source text is nice for procedural macros, but we're not going to go too much into detail on that. Do you want to talk about all of these unsigned and signed add and subtract methods, Ben?
I mean, it's a menagerie, right? Where for every possible integer type, of which there's like 8 or 9 or something like that, right? U for all the sizes and I for the sizes, and then literally a U size and I size and that kind of thing. You have, add and subtract on all of these. And then all of these, you have like checked variants and overflowing variants and saturating variants and wrapping variants. And so now the newest additions are, if you have an unsigned type, but you want to do various checked, add, etc. operations on signed types, you can do that now with these new methods. And if you have a signed type and you want to do various checked, overflowing, etc., add, sub, etc., with an unsigned type, you can now do that, and it does the right thing for you. For some reason, I'm not sure, the subs are only defined on the signed types and not the unsigned types. I'm not sure why that is. I'd be curious to ask. It's possible that it's kind of like no one's... in many cases, right, I read a lot of Reddit, and lots of users are always like, why doesn't Rust do this? And like, I think people have like this glorious like opinion of Rust, where it's kind of like, oh, like Rust must have a reason for everything it does. Sometimes it's kind of like no one's ever asked for it before, right? It's not always like, perfectly considered, where like the absence of a thing means that like, it's been deliberately like, rejected. It's kind of like, usually if a thing seems like it should exist and doesn't exist, no one's really just gone in and like, proposed it and then made it. So if you out there have a need for, say on U8 checked sub signed, for example, go and add it.
Yeah, go for it.
It's kind of an on-demand thing, so get involved.
Well, watch after this episode drops. We're gonna have like 5 PRs with people submitting that exact method.
Mm-hmm. Mm-hmm. Mm-hmm.
The next one I wanted to talk about is btree set and btree map have gotten methods that let you access the first and last elements. And this is kind of interesting because even though btree sets and btree maps are like one of their primary attributes compared to, a hash set and a hash map is that they are ordered. They actually order, in the case of btree set, their values, in the case of btree map, their keys. And so if you iterate over a btree set or a btree map, you get the values or the keys back in order, according to the implementation of the ord trait. But that sort of implies that they have a beginning and an end. But previously, if you wanted to get the first, like ordered first element of a B-tree set or a B-tree map, you had to like call the iterator and then call next and then call unwrap because you knew that it was non-empty. Or if you wanted the last one, you had to get an iterator, reverse the iterator, and then call next or call next back. So it was really like involved when fundamentally these collections are saying we are ordered. And so now we have a stabilized API that lets you just access the first and the last, which I think is a nice sort of rounding out of the API. I also wanted to talk about the new std OS FD module. So what's nice about this one, and I think this one landed a little while back. I think it landed in 163. So I'm not sure why it's called out here. But this basically has types like borrowed FD and owned FD, which I think we also talked about in the 163 episode. I honestly don't know why it's here, because I think we've already talked about it in the past.
What does it say on the stabilization release? Was it just by accident listed there?
I think it's listed here by accident because as far as I can tell, it was released in 163. That's also what the documentation says.
I see. Maybe it's there to make sure you're paying attention.
Yeah, that's right. Okay, deep dive into the changelog time. What do we got here? There were a bunch of changes internally in Cargo this time that I thought were kind of interesting. A lot of them are to enable the use of sparse registries, which we're going to talk about in 168. But some of the ones that are visible right now is that you can now no longer publish to a registry if you have source replaced crates.io with that registry. So that is, if in your Cargo configuration file, you've set up a source replacement, and I'll link a little bit to that in the docs for that in the show notes. If you set up a source replacements for crates.io and you call cargo publish, in the past, it would try to publish to the replacement registry. And that will no longer work. That's just going to error, which sort of makes sense because you don't want to give away your crates.io token to some random registry that just happens to be used as a mirror, for example. And the other one, and this is very clearly in the preparation for sparse registries, is that cargo publish will now block until it sees that the published package has actually appeared in the index. So previously, cargo publish would just like send your crate to crates.io and then return on the command line. But in theory, at least, you could run cargo publish and have your friend on the phone, and like the moment cargo publish returns, you tell them, okay, try to build your thing now or run cargo update. They run cargo update and then they cry back saying, no, I still don't have the version. And now cargo publish will actually wait until it appears in the registry. So now when it returns, your friend will actually be able to grab it. One of the reasons why this change landed and why one of the reasons it's relevant is because not just for sparse registries, but certainly it's more apparent in sparse registries. It can take a little longer before something appears in the index because there's more caching involved here, because now we're talking HTTP instead of Git. And so the delay until something is visible might be a little bit higher. And so cargo publish will now expose that to you as the publisher, which is useful if you're doing things like a workspace publish, where you actually have to publish multiple crates that depend on each other. You don't want to try to publish the next crate until the previous one is visible, because then your build of the second one is going to fail because it's going to try to download the first one that you just published. And I think publish also got a flag, and I forget what that flag is called. It's like no wait for publish or something, so that you can call it and not wait if you don't want the command to block. Another pair of changes that landed was that the Rust standard library will no longer link to libresolve or libiconv on macOS. We never, like, the standard library actually doesn't make use of either of those libraries and hasn't since like 2017 or something. So this is entirely just an oversight where we just happen to still link against them because in the past we needed to, and no one realized that link step was no longer necessary. And this should lead to slightly smaller binaries and slightly fewer build problems on macOS.
Maybe linkers need unused link warnings.
Yeah, I mean, you're not wrong. At the same time, linking against something that you're never using, at least in theory, shouldn't really add to your your binary size because you're not actually linking anything in. The place where it matters is that you still then require that people have that library available on their computer, whereas now that's no longer necessary. You don't even need to have libresolve, and your build will still succeed.
The only thing I wanted to call out from the detailed release notes was in the ASM macro, which was stabled about a year ago, which is inline assembly for Rust. Like many things, it gets stabilized as an MVP and then is developed later. And one of the two major things, in my opinion, that are missing from the ASM macro were symbolic operands and const operands. ASM sim is the symbolic operand half of that, and it was stabilized in this release. And so if you want to use symbolic operands in your ASM, it's now totally stable, which is great. And I'm pretty sure that ASM const is coming up pretty soon too. I think it's in the final comment period right now as we record, so it should be within a few releases.
Nice. Another thing that landed in this release was a soundness fix around lifetime constraints in opaque types, so impl return types. Ben and I both looked at this and went, I don't think that we can accurately explain exactly what goes wrong here or what the fix was. But very, very basically, there was a soundness hole where if you had a return type impl where the actual type you returned had a lifetime parameter in it or had a lifetime associated with it, but the trait after impl implied some longer lifetime, like static, the compiler would just let that be okay. Like if you returned an ampersand stir from a function that, was just referring to some local variable, for example, so it has a short lifetime, it would allow you to return, a reference impl asref stir plus tick static, and that would just work.
I don't think it was quite that simple.
It wasn't quite that simple, but that was roughly what's going on. We'll link to an exact description of the problem.
I believe the reproductions all involve more than one lifetime. So I think it was a lifetime inference problem.
Yes, there's multiple lifetimes and multiple layers of traits and impls. So it's not quite as simple as what I just described, but the gist of it is sort of like that kind of lifetime confusion when going through an opaque type. And that's fixed now, so you never have to think about it again.
I think the main takeaway is that under the hood, there's all kinds of unsoundness bugs being fixed all the time. And I think right now the biggest thing I had in the last year was the types team is now taking ownership of the type system with the eventual goal of formally verifying the type system and any future improvements to it, so that it doesn't kind of get out of hand, right?
Yep.
So we can first of all know that what we have currently it works and is sound, and then we can extend it with things like specialization, which would drastically increase surface area of type systems. So you want to make sure that you do it right, which so far has not been the case with specialization, which is why it's been unstable for 6 years.
Yep.
So
there was another lifetime related thing that landed, which is you can now use memtransmute to transmute between two instances of the same type that differ only in the lifetime parameter. So that was a nice little potential quality of life change for anyone who does that kind of transmute. A bigger change, or arguably not a relevant change, but it might matter to some, is that Rust now upgraded to using the version 15 of the Unicode standard. And among the thing that landed there is support for 20 new emoji, such as the ginger emoji and the pink heart, which is very, very exciting. And also 8 symbols for celestial bodies. So if
you've ever wanted to use the Unicode symbol for the make Ort cloud object, now you can.
Yeah, it's very exciting. I'm psyched for that one myself.
Actually, make might be an asteroid belt object. Hold on, I can look it up now. Oh, it's Cooper belt object. Okay.
And then I think the last one I had for 166 is another Clippy lint that was uplifted into a real or rusty lint, become a real boy, so to speak, is for loops over fallibles. So this one's a little weird. It's a lint that tracks if you try to do 4x in and then an option, or 4x in and then a result. And the reason why you want to warn on this is it comes up in places where people didn't expect this behavior. So first of all, result and option are both iterators. They're both collections, which is a little weird, right? You can have an option and you can call dot into iter on it, and you get an iterator that yields the item inside the sum if it was sum, and otherwise it yields no elements. And same for result. This is surprising to people, but often people don't really make use of it, and that's fine. I wouldn't expect you to. But where this comes up as weird is, imagine that you are calling a function that returns a result or an option, and inside of the sum or OK variant is an iterator. So you write something like for, whatever in foo, like call the function foo, and then you forget to put a question mark and you put a curly brackets. That will compile just fine because foo returned a result and result is iterable, so the for loop will work, but it will only go through the for loop once with the value that is the thing that you really wanted to iterate over. And so you get all these weird errors or warnings inside of your loop saying, hey, this item isn't of the type that you expected it to be. And so this lint catches that. It says, you probably wanted to use a question mark here and then iterate on the thing that's inside instead. So it's one of those lints that just catches a pretty subtle kind of behavior that I think people don't really expect to happen. I think that's all for 166.0. Did you have anything else in there, Ben?
That's it for me.
All right, so there's a point release to 66.0, so it's 166.1 as well, that fixes a potential vulnerability where SSH host keys aren't verified by cargo. And this only happens when you have cargo access Git over SSH. And you might think, well, whoever does that? And it turns out that this happens somewhat commonly because people have their SSH config, so not their cargo config, but their SSH config say, if you ever see https://github.com, use ssh://git@github.com instead. And the reason they do this is so that they can git clone using just the HTTPS URL, like the thing that's in your browser, but still be able to push to it over SSH without having to do anything manually themselves. It just kind of works. But this has a poor interaction with cargo where, cargo accesses the crates.io registry using the Git protocol, using https://github.com. And that instead of takes effect there too. The same applies to any Git dependencies that cargo might fetch for you. And so those are all subject to the same kind of Git config and will now be using SSH and then won't be checking the SSH host keys because of this particular issue. So the solution to this is, well, upgrade to, Rust 166.1 and this problem goes away. The broader solution here is you probably shouldn't have this in your Git config in the first place. Rather than using instead of for GitHub URLs, you should use push instead of, because you're not pushing to the crates.io registry or to any of your Git dependencies. So push instead of will only rewrite the URL that Git uses when you're trying to push and not for pulls. So that's another way to fix this problem that fixes it for the broader class of your configuration isn't quite right in the first place.
All right, 1.67. Let's get to it. The first thing here, the must-use attribute now works on async fn. Well, I guess the idea here is that futures. So the must-use attribute just is a thing that you can put on a type or on a function, which says, hey, like whoever calls this, whoever gets a function that returns this type, or whoever calls this function, they should use the result in terms of they should not just drop out on the floor. They should not just do foo paren semicolon. They should at least be required to do let _ equals foo to acknowledge that they want to actually get rid of this type. This is a way of making sure that folks can't ignore it. If there's some types shouldn't be ignored, like a result you probably actually want to process the output of. And so in this case, now the must-use attribute now works in async fn, where if you recall, async fn rewrites your function to return a future under the hood, and futures have already implement must-use because you don't want if you have a future, you want to actually await it at some point. But what if you actually wanted to force someone to use the inner result of the future? And so now the must-use attribute on an async function will now also trigger if you don't actually use the result of calling await on a thing if it's marked must-use. So it's a nice little transparent thing that makes sense given the async fn and what the kind of interface it tries to provide.
Yeah, it's another one of those sort of aligning async fns more with just regular fns, have more things work the same. The other thing that landed in 167, and this has been a long time coming, is a complete replacement of the implementation of the multi-producer single consumer channel in sync. So this is stud sync MPSC. It used to be that the standard library had its own implementation, and since 1.0, there have been a bunch of implementations that have developed out in the Rust ecosystem that just are across the board better than what was in the standard library. And so for a long time, there's been debate about, well, should we try to bring one of those implementations into the standard library, similar to what we did for the hash map implementation, for example, which is now backed by the hash brown crate? Could we, rather than try to maintain an N+1 implementation of channels, can we just use one of the ones that are externally? The one that ended up being the primary contender here is the one from the Crossbeam crate, so Crossbeam channel. And that one is it's faster, it is less error prone. Like, there's a panic in the standard library channel implementation, and the issue for that has been open for I think since 1.0. And so now they've finally gotten to the point where they've ripped out all of the old channel stuff, and they're now using the implementation from Crossbeam channel instead. And it doesn't change the API at all. It just means that now your channels should just be way faster and not have this weird corner case panic and stuff. So just behind the scenes, things are better now.
And this joins the scoped threads from Crossbeam that came earlier last year. So gradually moving more and more things from Crossbeam into Stud. What's next, John? What's next from Crossbeam that you want to see in Stud?
So Crossbeam is interesting because it's a little bit of a weird crate, right? It's labeled as tools for concurrent programming, and that's really what it is. It just has a bunch of, I don't even want to say primitives, it just has a bunch of concurrent programming constructs, and they range everywhere from a full epoch-based garbage collector to very low-level things like cache padded, which is a type that takes an inner type T and makes sure that it is the size of a cache line, which ends up giving you better performance for concurrent workloads because you get contention or false sharing for things if two values appear in the same cache line. So it's spans the whole range from a very complex implementation of an algorithm to a very low level primitive. I think realistically, the more involved something is, the less likely it is that it should be in the standard library, because at least in my mind, the standard library should hold things where there is one clear implementation of the thing, as opposed to things where there are lots of options you could choose. So arguably, even a channel is maybe weird, but it's common enough that it's in there. But I wouldn't want it to get epoch-based garbage collection, for example. That seems too ambiguous to place in the standard library or too prone to change. I think the next thing that I might expect to see move into the standard library is something like cache padded, for example. I think is a decent candidate for something that the standard library could just provide. Atomic cell, maybe, although even that one is a little weird. This is essentially, you have a storage location similar to the other types in the Stud atomic module, where it can store an arbitrary, I guess it's like an arbitrary T in potentially a lock-free manner that you can then access, or you can replace atomically or take atomically. But I haven't seen an effort to bring either of those into the standard library. So there's still some value for Crossbeam for the time being. Another thing that's stabilized in 167 was the non-zero types associated value bits. Do you want to say what this is, Ben?
I mean, briefly, it's kind of like if you have the basic primitive integer types, and so you have a U8, there's an associated constant on those. It's U8 : uppercase bits. Which just gives you the value 8. And if you have U32 : bits, it gives you 32. And so I guess we assume it's for macro authors to kind of operate generically over primitive types. And so this is kind of just brings the non-zero, because there's non-zero versions of all the primitive integer types. This just brings us up to speed with the same kind of thing, the same interface, essentially.
All right, I think we're down to the changelog, the last changelog for the episode. Let's see what we dug up here. So one of the things I found is that in a previous Rust release, Cargo added a mechanism to basically protect itself from zip bombs. So zip bombs are compressed files that when you decompress them, they turn out to be way, 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 way larger than the input file, like potentially infinitely large. And so Cargo landed a fix for this a little while back that made it so that it stopped decompressing after it reached like a hard size limit. I think it was like half a gigabyte or something. It would just stop unpacking. And they've changed that now to be, Cargo is now aware of compression ratios as well. So if you try to decompress a .crate file, which is really just a .tar.gc, and it ends up being more than 20 times larger than the input file, then Cargo will stop. So this is like, it probably doesn't affect anyone reading this, but it's an interesting case of a more flexible way to protect.
What's like a normal, like a basic compression ratio for like just normal text files? Isn't that like more than 20?
It's interesting. So they did an experiment over Cargo's dependencies, and they found that the compression ratio was anywhere from 2.92 to 18.4. It's a pretty broad range here. And I think the high ones are crates that are relatively small, but like have a bunch of constants in them, for example, so they compress really well because the contents do a lot of repetition. You know, or if you have a crate that has a lot of repetitive tests, then maybe it compresses really, really well. So I don't know. It's interesting to me that 20 was like chosen as the right number, but at the same time, doing a sample of Cargo's dependency graph seems pretty reasonable.
It seems fine to make it low, and then some complaints, I can always make it bigger.
Yeah.
So
another one that I spotted was that Rust-C will now optimize field ordering by grouping m times n to the power of n-sized fields with equivalently aligned ones. Do you want to give an intro to this, Ben?
I mean, padding and alignment. If you know what those are, if you don't, then congratulations, you are blissfully unaware, which I envy you. So for Rust, if you have like by default any Rust struct is what's called repr Rust, where repr Rust is unstable. It means that Rust is allowed to reorder the fields in your struct however it wants. In C, it's kind of like, I wouldn't say it's an art, but it is like a thing you need to think about, where if you have a struct in C, for example, it will lay out the fields in order of declaration. And you can do better than this, really, because of alignment and padding, which I don't want to get into here. Generally, the idea is you want to lay out fields in order of largest to smallest. And this will most efficiently pack your structs according to padding and alignment. And so in the past for Rust, say you have an array of like 4 U8s or whatever. In the past, it would order that array field with the alignment of the U8s. And now it's essentially considering the array itself as the alignment and like push it further up in the struct. Is that how I'm understanding it correctly here, John?
Yeah. So I think you're right. I think it's basically previously a U8 array of length 4 would be aligned and ordered as though it was a U8, and now it will be aligned as if it were a 4x U8, so a U32. And I think one of the reasons why this change landed is because there are a bunch of more efficient CPU instructions, for example, that you can use, or even SIMD instructions that you can use on arrays if they are better aligned than just unit aligned. So better than just aligned to the type of an individual element. If the whole thing is aligned as of the multiple of the size of the array, then you can do a lot better. So for example, in the U8 by 4 case, if it's only aligned by U8, that means that it might not be 4-byte aligned, like U32 aligned, which means that there are certain SIMD instructions you just can't use on that array because they require 4-byte alignment. And so this is really just making the alignment of and order of arrays be more sensible or more amenable to optimizations down the road. I also want to call out that we now have a new tier 3 target, which is the Sony PlayStation 1, which of course is a lot of fun. Everyone's using that one these days.
If you want to make a demake of your favorite modern game on the PS1, you can use Rust for it now. There you go.
Oh, sweet.
Play it in an actual PS1 emulator, I assume.
Yeah. They also removed the Linux kernel targets, which I thought was interesting until I read the description, noticing that these aren't actually used by the Rust for Linux project. So these are targets called Linux kernel that aren't used for the Linux kernel. So it makes a lot of sense to remove them. But the headline for it was a little confusing.
Right. So the any targets there are like their target specs. They're essentially just collection of configuration values for the code generator, essentially. And last year, I helped stabilize on x86. If you want to compile a program that's kind of like designed for bare metal, there's now a new target called x86 64-unknown-none, which is appropriate for if you're doing a kernel level stuff. And I reached out to the Rust for Linux folks back then, and I'm like, hey, would you be interested in using this? And actually, they have their own like weird thing they're using. And so I knew back then that they weren't using it, so I wasn't sure who was using it. And it turns out no one is, as far as we can tell. And so, if you want to compile, say if you were, for whatever reason, compiling against this target, feel free to begin using the x86-64 unknown none instead.
You're just shilling for your own target here, Ben.
Yeah, I am. So I get paid every time someone compiles code. I get royalties.
Nice. Every time someone runs like Rust up target add.
Yeah.
There was one more like little neat improvement I saw, which is that mere constant propagation now has some data flow analysis going through there where it can detect more cases where values in your program actually are derived from constants in your program, which in turn enables other optimizations down the road. And it can now do this, like if you have the example that's given in the PR that lands this is if true, braces 0, else braces 0 or 1 or whatever, then now Mir can use data flow analysis to realize that X is always a constant with the value of 0. And use that then, further later in your program, it knows that X has the value of 0. It's not runtime dependent and can run optimizations based on that. I thought that was a neat improvement to Mir that was worth calling out.
I wanted to talk about one of these things here, which is removing the drop order twist. And so there's a fun thing here that's kind of like, let's begin with the idea of what is drop order. So think about if you have like a foo and a bar struct, right? And that they both have, like if foo has a destructor that prints foo, and bar has a destructor that prints bar, right? The idea here is that it is possible with this to observe the drop order of foo and bar. And drop order is kind of an implicit thing. Obviously, there is like a std mem drop function, which you can use, which is kind of a silly no-op. It's hilarious. The best function in the standard library, where it just takes a thing and then does nothing at all with it. And it's kind of like a way of calling implicitly the drop function for any owned type, essentially. And so with this, or with any of these things, you can observe how Rust implicitly orders drops. And so because of that, it actually matters when, there are other reasons too why it might matter, but with this, it's really easy to do if you wanted to go to the playground or anything and just try it out yourself. But let's say, for example, you had like a single statement where you have let X equals and like a tuple of like foo and bar. And that if you compile this program, at the end, you would see it print foo bar to show that foo got dropped first and then bar. Easy enough, left to right. Now let's say you have a program where it's let X equals foo, next statement, let Y equals bar. What do you think happens, John?
It's inverted. It has to drop Y first.
You're right. And so because you have named foo and put it into X, and so in general, the compiler wants to assume, just to keep things simple, that you might have used the value of X when constructing Y, which means that if you freed X first, when you went to free Y, you'd be operating on invalid memory. And so this is an RAII thing. So this also happens in C++, where if you have bound variables, they get dropped in reverse order. And so the difference between this and the first example, where you just had a single statement, which was, let X equals, tuple of foo and bar, is the idea of a temporary. Right. And so a temporary value is a thing that never gets bound to any name. And because it never gets bound to anything, we can understand where it gets used, just kind of exactly one place. Right. And so we don't need to worry about dropping it in a weird order. We can just do it. But in the past, there was actually some weird behavior with temporaries as part of the conditions in if expressions. But only with a very complex sort of things. We can link to the actual issues here. But the gist is, if you were making temporaries, it's just essentially calling methods on things that generate values that weren't then bound for anything inside of the expression of an if, and you had various logical ands and ors in there, the order in which these were dropped was all messed up. It was like, it's saying here, if you have like, 4 and conditions, it would drop them in the order 2, 3, 4, 1, which kind of like, again, not easy to observe. It wouldn't make anything unsafe. It's all totally safe. They would tell you if it, wasn't, it's still under the hood tracking scopes and tracking lifetimes, but it's very surprising and kind of just one of those things where it's kind of like, oops, an error that happened in the very beginning in this thing, destructuring certain things, and no one ever bothered to go back and fix it.
Yeah, it's like I think the general property is it will drop the first part of any conditional expression last. That's what it would do.
Right. And ideally, you would like it to happen in the same order as any other statement, which kind of like, left to right.
Right.
Yeah, you kind of like, there's no reason not to, just for, making it more consistent, more understandable, more learnable. And so this mattered because there's a new RFC out for a thing called if-let chaining, which now combines let bindings and temporaries and if conditions. And so we talked before about the idea of the let else thing. This is kind of like, it's a totally separate, a different improvement to the if let handling, which lets you use and conditions. And so, for example, let's say you have an option containing an int, right? You can say, if let sum foo equals the option and logical and foo equals 4 or whatever. You can then have this. And so the idea of chaining instead of if lets, and you can even like chain multi, have if let foo equals bar and if let, x equals bar, you can then, use the results of like prior matches in the next one. So it all works out because it's all short circuiting. And so if one didn't succeed, it wouldn't even bother going on to the next. And so as a result of this, they want to really clean up all of the drop order handling. And this is just kind of like, now if you were looking forward to the if let chaining, this new development unblocks that work essentially by finally fixing the drop order twist. It makes the language simpler, more obvious, more elegant, and makes it possible to have this if-let chaining, which I think it's coming in like maybe 2 releases or so, I think. I'm not sure if it's been stabilized yet, but I think it should be on its way.
Yeah, I think if-let chaining was actually originally stabilized and then unstabilized before it landed on stable because in part of this drop twist issue.
Mm-hmm.
So it's I'm pretty excited about that. I mentioned the if chain crate earlier, and if let chains would make that crate unnecessary because now you can just do it with regular chains of if-lets. Let's see. Oh, there's the inconsistent rounding of 0.5. Do you want to talk about this one too?
No, you can go ahead and do that.
Okay, so it turns out that floating point numbers are complicated, and if you didn't already know the floating point numbers are complicated, then again, you live in a blissful world, and I wish I could be you. But basically, when you write floating point literals in your code, there are some literals that just cannot be accurately represented by whatever floating point type that you use. So if you write, I think the canonical example of this is if you write 0.3, it doesn't actually get represented as 0.3, or is it 0.1 and 0.2? There's some like 0.1 plus 0.2 is not equal to 0.3. And part of this is because floating point values can't encode every possible rational number because there's an infinite number of them, but you have a finite number of bits. So they have to quantize in some way. And this has a number of weird implications for what happens when you write programs with floating point numbers in them. And one of them is that if you have the number 0.5 and you try to print it in Rust and you try to print it using 0 decimal places. So this is like, format ln, double quotes, curly bracket, colon, 0, end curly bracket, no, dot 0, end curly bracket, double quote, and then some floating point number whose value is equal to 0.5, it would get printed as 1. And you might think, well, that's not that weird. 0.5 gets rounded to 1. Sure, why not? Well, it turns out the 1.5 and all of the other half integer values round to the nearest even number. Now, why? Again, floating point numbers are weird, but all of the other half integer values will round to the nearest even number. But 0.5, the nearest even number is 0 because 1 is not even. And so in 167, a change landed so that now 0.5 and only 0.5, we're not talking about any other floating point numbers, will now get rounded to 0 when print with 0 decimal places. So for all of those of you who were eagerly awaiting this change, it has now finally landed. I think that's all I had.
And that's it for me too.
Nice. I wanted to call out one change that's coming up in Rust 168, just because there's a post about it on the Rust blog as well, which is that in Rust 168, Rust is going to bump the version of the Android NDK that gets bundled with Rust. That changes a little bit about the minimum supported API level and stuff. There's a blog post about it, but I wanted to give the heads up for anyone who is actively monitoring Rust releases and might be curious. I'll link to that as well in the show notes.
One more thing in the Rust blog is that if you want to start testing the new cargo feature with sparse registries, I believe there's a post for that and a call for testing. So it won't become the default in 68, but I believe it will be landing as a stable option in 68.
Yeah, it's very, very exciting. That's from the Inside Rust blog. I'll link to that in the show notes too.
Ever been stymied by going to cargo build and it says, fetching, cargo index for a long time? This should alleviate you and make you very happy.
Yeah, I'm very excited for that one. I think we did it, Ben. I think we're all the way through.
Another successful triple episode. I feel like we shouldn't do it again. It seems like we expect Rust to kind of over time gradually come out with fewer and fewer cool features, but there's always a thing to talk about with us, really. We love some of our own voices. We just can't, we are excessive narcissists, really. And so I think in the future we should go back doing two. Next time we definitely will. We definitely won't do this again. I guarantee it. It'll never happen. Definitely won't happen.
I will give no such guarantee. Next time we may do one version. We may do 8 versions. Who knows? I'm going to keep you on your toes. All right. We will talk to you all next time when Ben and I next rise from our chairs that we normally just sit in permanently in between recordings and just fiddle our thumbs. Twiddle our thumbs.
My thumbs are so strong. You have no clue.
That's right. So we'll see you all next time.
All right. Bye.
Bye.